Live from New York, it's Ask an Engineer.
Storming Liar. Welcome to Ask an Engineer. It's me, Lady Ada, the engineer with me, Mr. Lady Ada, on camera control. Got a fun show for you tonight with lots of musical guests of the sort, I guess. A lot of robot guests,
Yeah,
and some cool historical
you can
stuff.
make robot friends and robot bandmates.
Oh, cool. All right, well, let's get right to it. Why don't you tell people about the discount code
That's
and
right.
what's on the show tonight?
Tonight's show, the code is Redbug, 10% off in Adafruit Store, all the way up to 11:59 p.m. Eastern Time. We have a gigantic show tonight with a lot of retro stuff, a lot of top secrets, a little bit of a different show. So to celebrate that, use code Redbug on checkout. Gonna talk about some of our live shows, including Show and Tell. JP and Aaron just hosted, and I got a project that I'm going to talk about that was on the Show and Tell. Super cool, so stay tuned for that. We're going to go over Desk of Lady Ada and some of the great search that we did this week, JP's product pick of the week. And then we have a big retro tech section because it is Marcintosh. We're going to do some factory footage, so 3D printing, on MPI, and then set a new product this week because we're going to double up the new products next week. We're going to have a huge top secret section this week, so stay tuned for that. We're going to answer your questions. We do that over on Discord, adafruit.it/discord, or discord.gg/Adafruit. That's where we collect all the questions and we answer them throughout the show, but mostly towards the end of the show. So put them up there and we'll answer them. All that and more on, you guessed it, Ask an Engineer. So, Lady Ada, the code is Redbook. We'll talk about why it's Redbook soon. People get free stuff as they add things to their cart that helps pay the bills here. An independent venture, capital free, loan free, independent woman owned manufacturing company. Had no banking issues over the last couple of weeks. That was kind of nice because we're supported by y'all. So, when you add stuff to your cart, what do you get?
First Ada Bank Republic. Okay, starting off $99 or more. We're still giving away Proto half-size breadboards. A great little giveaway to take your solderless breadboard projects and making them permanent. 149 or more, we've got the pink KB2040. I will say we're about to run out of the pink version. We'll be going back to Adafruit Black. So if you love PCBs, pink circuit boards, order 149 or more at the Adafruit shop and we'll toss one of these in for free. We actually had someone say, hey, I want to do a project, I need a microcontroller. And they're like, wait a minute, I got a free KB2040. Can I use that? And I said, yeah, the project you want to build, you could use the KB2040. They were like, yeah,
We're making it too easy again.
make it too easy
Now we just send you stuff that you know that you're going to need eventually, no
before
matter
you
what,
even need it.
before you even need it.
That's how it goes. 199 or more UPS free ground shipping in the continental United States, and 299 or more while supplies last. We still have a bunch of Circuit Playground Expresses. We're making them as fast as we can. It's our favorite microcontroller circuit board. Having this back in stock shows that nature and electronics are healing because we can get parts again. There's a lot of parts on this board.
Yeah.
LEDs, sensors, buttons, speakers, capacitive piezos, all this good stuff. Free with your order.
All right.
$2.99 or more.
We do a bunch of live shows. In fact, just finished up the show and tell. You can watch it on any place where we publish videos, which is pretty much everywhere. Lots of projects. Gonna watch the rest of it, but there was one in particular that I figured we would talk about now because the guide's gonna be going up soon.
Yes.
And I'm going to have to send a time-coded URL of a video to someone who's being jerky. So this is the idea behind a project that we're doing.
Yeah.
There's a lot of stuff going on with AI. It's actually not really AI right now. It's a language model. It does a prediction of the next word that's going to come along. There's like a token in the cloud somewhere, and it's just good at piecing together text that humans can like. Oh, this is the words. And so one of the ideas we had was, well, this is great for telling stories, fiction,
Yeah, making that stuff.
making up stuff, because that's what it's good at. So we thought, oh, this would be neat. So you could have a animatronic teddy bear, and you'd say, tell me a story about, you say your kid's name and a unicorn, and then it makes a short story and reads it. And if you remember things from earlier in life, in decades ago, there was Teddy Ruxpin. You put tapes in it. There was 2XL.
That was your best friend.
We have a 2XL video. It was an 8-track tape. And then there were things like the movie AI, and there was there was a bear in that. Super Toys. So we have a little demo of Melissa's working on this with a Raspberry Pi. It's a speech recognition. But I want everyone to remember that these are going to happen and you can build your own, and maybe you should, because maybe you'll want to have control over what information it's generating and the stories and the if the microphone's on or not.
Yeah.
So we have an IoT Bill of Rights that we wrote probably 10 years ago now, that eventually it gained a little traction. We started to notice some devices have an off switch, so you physical off switch, so you know there's no microphone. But the idea is, like, as always, these technologies come along. We want people to be able to make their own things, and there'll be lots of different ways to do this. So and there's of course an open source way to do it. So we'll have that pretty soon. But just want to make sure folks know that the idea is you make this type of thing yourself, and
You can hack it, mod it.
yeah, and so I think there's a lot to learn and understand with these
Yeah.
large language models. But we always have a kind of a different take on things, which is this is more like, skateboarding. It's like, oh, watch us do this trick with this thing, and it's good at like generating fiction stories. So like, why don't we have it make fiction stories?
Yeah.
So you can catch.
There was this like time for the last, not it wasn't really recently, but like 5, 10 years ago, it was all about like you are a storyteller. Like everyone's like, it's all about storytelling. It's like, well,
Yeah,
here we have a storyteller. Otherwise,
yeah,
it's like a bullshit artist.
yeah. And so I think it's kind of neat, and I think that's the way, we don't do like fighting robots and stuff like that. Plenty of people do it, super cool. We like to do like robots that like paint or do art, or like robot companions, or like the video that you saw in the beginning. It could be a band member and the robot can make music with you. So this is similar. We want maybe robots to be companions to tell you stories, and kind of combine lots of different things and make it very personalized with like maybe your kid's name. And it doesn't need to be internet connected too. You can have all this stuff happen. And
Yeah, there's local LLMs too.
yeah.
Yeah,
So, anyways,
that could be neat.
let's talk about Desk of Lady Ada. So that's every Sunday. Um, we do it in two parts. What'd you show off this week?
Show some of the stuff that's coming soon, including the USB host Feather. I did a little demo showing it reading HID data from an SNES like joystick type
Yeah,
thing.
we have some top secret videos that we'll show.
Yeah, we'll show longer videos with me explaining what's going on, and then I showed off the IntelliKeys, which is kind of neat, and we'll be using that with the USB host shield, and also some e-ink demos with the new e-ink Feather prototype as well.
All right, then we do the great search. That's when you use your power of engineering to help people find things on digikey.com. What did you help people find this week?
So this is following up on last week's video where I showed how to find a UFL to SMA adapter for attaching a antenna to our LoRa or RFM 1669 900 megahertz uh, Feather RP2040 board. So this time I was like, okay, let's do the second half, which is how do you locate a good quality whip antenna? And, I do a 15-second introduction to how to, spec an antenna. And already we had to delete comments of people being like, you did not get every possible detail correct about antennas. Yes, it is a 15-second quick overview.
I mean, you didn't.
I do not teach the entire semester of 6013,
Really?
propagation of electronic
I want my money back
magnetic
from that
electromagnetic
from that YouTube
waves.
short.
I know. Does it fit and listen to TikTok? It's probably not a full education, but you do get some ideas of what to look for and what to look for in the data sheet as well for getting antennas. It'll just get you started. Then you can always optimize and iterate.
All right, and then every Tuesday we do JP's product pick of the week. Here's a highlight from this week.
That's my product pick of the week this week. It is the return of the Cutie Pie SAMD21. Some of the things I love about it: 1, USB-C. 2, the fact that it is USB HID compliant all the way through, so you can do MIDI projects with it, keyboard projects with it, mouse projects with it. Also, because of the STEMMA QT port on there, you can plug in the many I2C peripherals that are available out there, and especially the ones that have that STEMMA QT port. It makes it plug and play. WeChuck adapter lets you use various Nintendo accessories and a little OLED display, so you can see no soldering, just plugging and playing, and you can get a project up and running. That is my product pick of the week this week. It is the Cutie Pie SAMD21 Cortex M0.
All right, and don't forget on Thursday, JP's workshop, and then on Friday we have Deep Dive with Tim. So, big segment this week. All right, all month long is March and Tosh. It's also Women's History Month. There's also something going on every single day. We wanted to do like the Museum of Technology, maker stuff. Like here's every Arduino board, electronics and computers that influenced us, and obviously Macs,
Yeah.
especially old Macs. I think helped get us a lot of us here.
Yeah.
HyperCard we talked about last week.
Yes.
And just like really weird stuff. In fact, the stuff that we're trying to do for March and Touch, which is a month-long celebration of Retro Macs, is kind of the weird stuff. So the first thing that I wanted to show is the Quick Take camera. The Quick Take, yeah, I got it. Is it's the Quick Take 150, and this was digital cameras years ago. And if you look on Flickr, they have every Apple camera, which is all phones now, but then there's 3 at the bottom, and there's I think 3 pictures that were posted in the last year, and it's from our camera. So we still have it. It's like 26. It's 26 years old.
JPEGs have JPEG.
Yeah,
man.
27 years old.
That format in a while.
Yeah, so let's watch the video. We have we photographed ours, and then there's a little commercial. One of the things that I'm doing as we publish these stories and these old retro photos, and people are sharing their experiences. I'm trying to dig up the old ads of what they were saying, like this is the future, and see how it matches up to today's expectations and more. So here's the first one.
Before, after. Before, after. Before, after. How do you get from before to after? Simple. Introducing the Apple QuickTake digital camera. It makes everything you do look better than before.
And that was the manual that you can check out as well. And so this, do you know what this is?
This looks like what is it, like a trash can? No, it's a Roomba. No, what?
This is the
tallest Roomba.
This is the first Apple wireless trash can. No, this is a speaker that goes along with the 20th anniversary Mac, and yeah, and it's really a beautiful machine. They did this. We have a video with Johnny Ive, and it's from a long time ago, and you can see all that went into it.
Look at that fan.
Ethernet.
By the way, look at that fan there. That's like they would not let you do that now.
Yeah. All the TAM, and there's this giant umbilical cord style.
The connector is insane.
Yeah.
The connector is like what? It's like what aerospace monstrosity is it? Yeah. And they like SPDIF did not exist.
They really loaded up. It had CD-ROM, it had TV tuner, Ethernet. It was neat. And so on it though, there was when you started it up, there was this rendering, like state of the art at the time. This like,
Wait till you guys see this.
This 320 by 240 rendering. So I'm not gonna play the entire thing. It's just I'm gonna play some of it.
It is so 90s.
And everything about it is 90s. I love it. And so we're gonna play that. But check out. We're doing most of this on Tumblr. So check out adafruit.tumblr.com. And
I can just smell the RC Cola.
Yeah. And
Heads.
yeah, we'll come back after this video and show you some other stuff. But it's really neat to take a look at
really big
at how far we've come. So here we go.
There are some things in life that capture one's soul, like design that goes beyond the ordinary, compelling beauty and grace, a sweeping curve, the perfect line. In the pursuit of design, humankind continues to make better and more elegant solutions. From furniture to architecture to the tools we use every day, the unity of form and function can't help but make an impact on our lives. Balance, contrast, texture, color, and some deeper meaning. Art is design. Design is art. Life is kept exciting by the discoveries that emerge. They keep us looking forward, reaching for new ideas and innovations. Apple's 20th anniversary Macintosh, a design for the future.
Hey, Steve, what do you want to put on the center there? I don't know. Let's put another little one in the middle. Okay, that's fine. All right, so that's the 20th anniversary Mac, and more ahead. We have more days in the month. So the next thing, and this I thought would be a special treat for y'all out there and for our late Ada. This is the Apple II reference manual sent us by a kind person. I didn't ask them if we could say who sent it to us, but we have the Red Book, and this was I'll just show some of the pages.
It's actually gonna be handy when we do the floppy disk.
1978. No ISBN. It was like this was like sent out with like the
It's a manual.
yeah. You know, you want here's your computer. You get some schematics. So I'm gonna go to the.
It's Apple part number 4.
Yeah. 1978, and lots of neat stuff. Here's some. Oh no, what happened here?
Oh, I don't know.
Well,
Let me turn it back off.
well. Let's see what's going on here.
Oh, that's not a good overhead.
Yeah,
No.
who knows? Let's see. Well, luckily we just posted up photos and everything. Unknown why it doesn't have any signal on our
Oh, that's weird.
overhead. Little overhead.
It's our new overhead too.
Little overhead. Maybe I'll try now. Well, we also have a sticker.
Well, I love that half of this is assembly code. It's literally just assembler, like in the back, hand drawn.
Signal. I don't like this. There should be signal. There's no signal.
Main screen turn on.
Yeah. Well, the other thing it could be, and
Did I kick something maybe?
what? No, I don't think so. But I'm kind of determined now.
Okay. Oh, hey. Nice.
That's right.
Did you just unplug it and plug it back in again?
I defragged the hard drive.
You know, form follows function,
Yeah.
and function follows form. And sometimes you just have to replug the HDMI
Is cable.
design.
Yeah. I do have this giant cable that kind of runs everything.
Yeah.
Anyways, thanks for bearing with us. Our kid is teething too. I think she was gnawing the wires.
Oh, yeah.
Yeah. So why don't you find a schematic page? I think the
Well, this is just cool. So can I just show they're like, hey, by the way, here's like a mini assembler, and they just have like
here, just type this in.
just type this in. Like what's the thought process here? I don't know. Yes, this is their mini assembler by S. Wozniak.
Yeah.
And A Bomb. So that's kind of cool. So they have a couple different. They have the pseudo machine interpreter. Here's the floating point routine. So that's kind of cool. Neat. This is by Wozniak,
Yeah.
1977.
And you're probably wondering, boy, it'd be great if I can get a copy of this. Don't worry, you can. We link to archive.org where there's a copy of it.
This is all the assembly instructions and the flags and jump and whatever. Okay, here's the hardware, system timing and schematics. So they're like, here's how you put it together. Okay, no problem. Here's you just put it together. Oh, you start with the preliminary manual. Okay, so this is AC line, and they're like, here's some RF modulators you can use. Oh, do you want to maybe hide us? Because we're in the way of the cool text. Yeah, so you can get like the Pixieverter. That's a cool name, the Pixieverter. Or the RF modulator from Burlingame. So they're like, here's how you. It's interesting. It's like there's no drawings because it was really.
There's some in there.
There's some, but there's not a lot. So they're like, here's how you can wire stuff together. Here's how to connect RS-232, and they're like, yeah, no problem. You're just gonna get like a little piece of strip board, wire up a little resistor to level shifter bias transistor, and here's a teletype routine that you could code in if you wanted to connect to teletype. let's see. And then here's the layout of the main board. Oh, beautiful. It is a beautifully laid out board. I mean, like, look at that.
Yeah.
All the chips in a row. And this is the slots for peripherals. And like they're, they're just like, hey, by the way, like, here's the addresses and here's the, it's connected to a 74 LS series cassette jack, and they're like, here's the impedance for it. And it's like very, very low level details of like, okay, you want to connect to peripheral. It's like, if you're
Well, it's open source hardware before open source hardware.
if you're using a microcontroller, right? It's like you have your IO port, 8-bit port, and then they're like strobe bit, and you have some interrupts and the IRQ and like the ready and reset lines. It's basically the same thing. This is a beautiful drawing. I like these connectors, the famous power connector, which has plus minus 12, plus minus 5. Power supplies. I remember there was a couple articles.
Raspberry Pi GPIO or something.
It's like that, but it's not quite. I think it's a 5 volt. I think the logic. I actually don't know if the logic was 5 volt or 12 volt. I'm assuming it's 5. And then the memory map, and it's like, oops, made a little mistake here, so they redrew it. It's kind of nice that they didn't fix. They didn't clean it up. They're just like, oh, print, go to print. All the timing. Oh, this is a beautiful. But look at this beautiful drawing.
Yeah.
Oh, that's so cool.
Zoom in a little bit here.
Yeah, this one's nice.
Look at
This
that.
is the peripheral bus and how it connects back and forth between the different peripherals. The video generator, peripheral IO, onboard IO. And then, oh, hold on, go down here. You can see the speaker. Neat.
Yeah,
And
and
this
so
is the MPU 6502. And then this is the oscillator, and they have the little crystal driver here. So this like generates all of your clocks, and you're just using some, some simple 195. I don't know what that is, like an SR latch maybe. And then the RAM counters, and these are the RAM chips. So they're just like, hey, you just get a bunch of RAM chips. Yeah, and these are just like various little counters and dividers. Here's your RAM. It's just one big array. And let's see. The IO port. I like that they have all the the part numbers and everything. Yeah, and it's like here's a 553 quad timer. So this is how a lot of people are like, oh, you have a joystick, right, which is a potentiometer, but then how do you connect a potentiometer to digital circuitry? You use the input of the potentiometer into a 555 or a 553, in which case is a quad timer. And then the pulses that come out, you measure the width of them, and that tells you what the resistance is, because the capacitive is set here. It's fixed capacitance and flexible resistance. Then there's the speaker driver, just a simple, class A with a Darlington driver. And the little, yeah, I mean, it's like all very, it's funny. This actually would be a great, if you're learning digital circuits these days. I know like it's all done, emulator style now, but it'd be really cool for somebody to study and analyze like what's happening on each page. Like how are all the circuits used? Like look at this like 555 cursor flasher, right? They're like, okay, we're gonna flash the cursor on the screen. Well, there's just a 555 that does it, and it sends a signal to the video generator. And yeah, this is just the composite out. I mean, like amazing that he got composite out using just like this logic level circuitry.
and if you look at this is a sticker from 1978, not
instructions,
not bad quality. You can
well, they used lead back then.
Yeah, and you can see, this is where the his cut is, and we could peel this off, but we're not going to do that. We're going to store this in a safe place.
These are very vivid color. I mean,
we also wanted to kind of tell the story. So if you asked, like, who designed that Apple logo, a lot of people don't know. It was Rob Janoff in 1977, and he was an art director at Regis McKenna. Tasked to design a logo for Steve Jobs. They wanted something to show it was an apple with a bite out of it. You can look at the previous one. It's like this Newton ink drawing.
It was a beautiful drawing. Yeah.
Yeah. And they didn't want it to be mistaken for a cherry or any other type of fruit. And they also wanted to show that it was color, because that was a big deal, color screens. So
yeah. The
That
PC
was-
red color, and not it had like 8 colors.
Yeah.
very nice.
So continue to check out our retro journey. There's a lot of neat stuff in computing history, and it's fun to kind of watch some of the folks on the social media say, "Oh, is this a rendering?" Because it doesn't seem real. It's like, what do you mean Apple made a digital camera? Now there's
Yeah.
every phone's a camera. So neat stuff, and look at the hashtag Marchintosh, and you can see what's going on. There's a lot of people posting cool stuff, and that is this week's retro. Okay, it's Python on hardware time, and we got some stuff going on. The newsletter is gigantic this week. Thank you so much, Anne, for putting in all the work that makes this, I think, the best and most popular Python on hardware newsletter.
Yes.
So a couple bits of news, and then we'll go into what I think is a big story this week: MicroPython support for the Raspberry Pi Pico W. It is progressing. If you want to play around with it, you can check it out. There is Bluetooth support for the Pico W and MicroPython. There's a pull request in progress, and there's experimental builds already
Ooh.
that you can play around with.
Yeah.
Yeah. And you'll want to use our Bluefruit Connect if you want to actually use it. That's one.
Yeah, which I mean, we have a great app that implements and uses the Nordic, the Nordic UART standard, because BLE doesn't have a profile for UART, so like Nordic kind of made one up, and it's sort of standardized because Nordic has so many chips. So you can use our app. It's a great free, ad-free little chat app that you can communicate back and forth. And we just updated it on Android.
CircuitPython 804 release, couple updates, fixes and enhancements, the printing, the soft reboot message that works now, and then some board specific changes. Still have some new issues, but please check it out. We're going to be doing more updates, and then we'll be releasing, of course, probably like final as we
I think we're waiting on some GIF.io fixes, but yes, we're getting close.
getting close.
But it's whenever we do a big release like 8, there's always going to be a ton of churn right afterwards because we get so many bug reports, and we're doing a lot of work with IMX as well.
And then, of course, unending stories. I think some of the neat things in the newsletter is what's going on in the community, what other folks are sharing their stuff. This is PyDog. This is a Raspberry Pi 4 running Python, and it's a dog. You can make your own little
that's
dog,
cute.
make robot dog friend, not robot dog enemy. This is neat. Charlotte has an interview with Embedded FM. If you've seen her work, it's really great, and she uses a lot of Adafruit stuff, a lot of CircuitPython too. And then just go through and look at all of the projects and more. It is never ending. There's something to do with Python on hardware everywhere. If you have anything that you've ever wanted to do, stop here first and just get some ideas from physical computing, interfacing with things that maybe were never meant to be interfaced with, to making your own games, to a menagerie of hardware. It's happening, and a lot of it's because of the community of folks out there producing libraries, and that's what our big news this week is. We're up to 100 libraries in the community bundle. So that means what?
Right.
Thanks. Yeah.
Than library than
Yeah. Ah.
Libra.
So
Oh, they're Libras.
so why don't you talk about what are the community bundles?
Yes.
What's a community bundle? There's 100 of them now, and then maybe you can give an example of something that's worked out really well in the community bundle.
So we have the main Adafruit bundle, and that's the bundle that Adafruit employees and engineers and people that Adafruit pays. Write libraries for mostly our designs. And it allows us to support our hardware, and we kind of maintain them and keep them up to date and close PRs and issues and stuff. And then there's people who write libraries for CircuitPython that, again, will work through Blinka with any Linux computer or even desktop computer through a USB to GPIO converter. So it's like you write the library once, and then it runs everywhere that CircuitPython or CircuitPython or CPython will run. So we have like a couple hundred libraries. I don't remember how many. It's like 200 or 300 libraries. But then, I saw recently C Grover put in some analog to digital converters and like some PWM generators. and also Foamy Guy and some other community members have been working on a lot of Adafruit display IO, which is our display like sprite and layered base graphics engine for CircuitPython. You know, adding more like built-in devices like uh, gauges and scroll bars, not scroll bars, but slider bars, buttons, like other user interface elements by like building up the frame buffer image. And like they just need to have their own little object. And so they're kind of spitting out a lot of those graphical elements. And so there's quite a few in the community bundle. Anyone's welcome to do a PR to add your library, and there's some benefit to it. You're like, why would I do that? First off, we will automatically every time there's a new CircuitPython release, we will and every night that there's a new release within your GitHub repo or GitLab repo, if you've pushed a version update, like if you've tagged a new version, we will grab that code, we'll stuff it into the zip file that you can, you know, download every night that gives you all the libraries, all the examples, and then we'll also perform the compression, which I can't remember the name of, the MPY compress. We'll run that on your code so people don't have to like do that on their own. They get like the .mpy file. And I believe also if you're using our CPY pip, sorry, it's not micropip, which is the MicroPython version. It's circup, which is like an automatic updater for your CircuitPython boards to make sure you have the latest libraries. People will be able to get the bundle, and that'll automatic, you know, like instead of going to every repo, they go to the bundle. It has everything, and then they can update all their libraries at once, and it has all the dependency graph as well. So it's kind of just like our little way of making it easy for boards to automatically update themselves, code to know what dependencies they have, and like we make all the bundle very nice and pretty. So whenever I start a new project, I'll usually download the latest bundle so I can get all the latest libraries, because I'll be like, oh, I want this, and you pick and choose like a little
Yeah, go to
bento box.
circuitpython.org. You can always get the latest build for your board, and then you can also get the latest libraries that keep you up to date. And
Yeah.
there's a lot of UI element, dashboard widgets, all these things for the
And lots of sensors, and like, you know, we don't have every sensor and device. Like people are like, I want to add this OLED display, and I'm like, I don't have that OLED display. But if you want to add a driver, and you put it in the community bundle, and yeah, it kind of gets kept up to date, so it doesn't have as much link rot. I think
this is the big deal. I think that the next chapter of microcontrollers is this, where we've all spent a lot of time having the pile code that's kind of over. You can now just, you know, kind of do real-time stuff, and then like, oh, like how do I update my board? This is impossible. I can never find the latest firmware.
yeah,
that we made that easy. Now it's getting all the drivers, the
and
libraries.
the community bundle is also like automated.
Yeah.
You know, so it's like there's a human that does the final PR approval, but a lot of it is pre-checked for you and to make sure that everything is named correctly and within not our like coding standards, but just we look for like really obvious mistakes. We're like, hey, you like made you have like a serious typo that might mean that your code has bugs. We do have automated linters that check that for you.
Yeah. So hopefully this will continue to do what it's been doing, which is getting you making things, sharing things as fast as possible. Of course, you can dig in really deep and do a lot of other stuff, but this is when you want to do that project and you just want it to work and prototype fast. Great for educators. You're spending more time doing instead of managing.
And one more thing, we have a guide in the learning system on how to write libraries and submit to the community bundle. So if you're like, I want to do this, check out the learning system and just type in how to write CircuitPython library. It's one of the guides that comes up.
We deliver this newsletter every single week to your inbox. It's a separate site, adafruitdaily.com. And we don't harvest your emails, we don't track, we don't spam, we don't do anything like that. So go over there if you want. Or you can just read on the web. There's RSS feed for it too. All that stuff, it doesn't matter. We want you to get the best way to read newsletters to you. We're an open source hardware company. To prove it, we publish our files, we have guides, we do all this stuff. What's on the big board this week, lady?
Yeah, we've got a couple of guides. I think we have only like 2 guides this week.
Yeah.
Hiding us because it's
Well, I was gonna.
Well, but
Want to hide us?
Yeah, because we're kind of huge.
Bye.
Okay. We've got a super great guide from Liz. It's
Yeah, I can play video.
the MIDI controlled robot Lyra CircuitPython. She's been working on this for quite a while. I just thought it'd be fun. People are always like, "Oh, I want to make a robot harp." Harps are really big, guys, but a lyre is a small Mediterranean instrument that has fewer strings, and so it actually is practical to try to make a robotic version. Liz did a great job. It sounds beautiful. It's of course MIDI controlled. And she has all the files that you can build your own. I think, we've done the robot drumming machine, we did the robot metallophone, and now we have the robot lyre. So we're really close to having the full robotic band.
All
Super
right.
psyched about.
And we have a little short video we're going to play.
In this project, you'll build a robot lyre that uses MIDI-controlled servo motors to pluck its strings. The robot uses a PCA 9685 to drive the servo motors. It's connected over I2C to a Feather RP2040 running CircuitPython. The CircuitPython code listens for incoming MIDI messages over USB. If a note is played that matches the array, then the corresponding servo is moved. The build rests on a piece of acrylic paired with 3D printed parts. These include a cage that places the servos directly above each string, and horn extenders to pluck the strings. You can control the robot lyre with a MIDI controller via USB MIDI host, or through a DAW by configuring the robot as a MIDI output. See how you can start building your own robot band by checking out the Learn Guide at learn.adafruit.com.
And some factory footage. And that's what we do here today. All right, let's do some 3D printing. We have a speed up video. We're going to play that. Then we're going to jump right into INMPI and then a gigantic top secret section. So here we go. Hi on MPI, brought to you by DigiKey Adafruit. This week it's Nordic. Lady Ada, what is this week? It's new product introduction.
Glad you asked. This is the Nordic NRF 7002. It's their first Wi-Fi chip. Very exciting. We love to cover the new stuff from Nordic. Here we've covered like all the NRF 52, 53, the 91 series, and now they're kind of heading in. They're charting new territory. They're going into the Wi-Fi chipset zone with the N7002, so 7 series, which is Wi-Fi. And what's interesting about this is that this is a Wi-Fi like accessory chip. It doesn't, there's obviously a microcontroller of some sort inside, but you don't write code for it. Instead, you sort of load a binary blob, and then you can communicate with this chip over SPI or QSPI, and it does like the Wi-Fi part for you. It's like a Wi-Fi module, but it's just like the chip. It's very simple. It's fairly inexpensive, and it's very powerful. It actually has a couple things going for it. That because a lot of people might be like, well, why would I use this instead of like an all-in-one Wi-Fi chip, like an Espressif? There's reasons for using the NRF 7000. We'll talk about what those could be. So here's some details. First thing, they put, which I think is kind of the most interesting, is it does 2 channels. It does both the 2.4 gigahertz standard and the 5 gigahertz, and that's not usual. Most Wi-Fi modules and chipsets only support one, usually 2.4 gigahertz. Another thing is it has coexistence for like antenna, so it will not bash over, like if it won't transmit 2.4 gigahertz data while the Bluetooth is trying to transmit at the same time, and like thus collide in the air. You have a coexistence interface pin, so it knows like, okay, now I can go, and then they switch off turn by turn. It can, of course, act as a station or an access point for provisioning. It has QSPI as the interface, or SPI, so it can be either like very simple or very high bandwidth data transfer back and forth. And this is their glamour shot. It also shows that outline is all the components that you need to run this. So you have to, your standard crystal, a bunch of passives, looks like, one inductor, a couple big caps, some small caps, and that's it. It's very simple. It's very integrated. And then on the left, you see there's, I think, an antenna switch, a very low cost Balun, and then you just put in your antenna, your 2.4/5 gigahertz antenna, and you're good to go. So the host connection, as you see here, is you have the host MCU. They do target the NRF 53, I think the 52 and the 991 cellular series at this time. Well, you could use other host MCUs. I'll be honest, right now the code is really like optimized for their own. You see there is the SPI interface, there's the IRQ, there's the buck enable, and then the coexistence interface. So if your host MCU is, say, like I said, an NR53, you have a Bluetooth antenna, you don't want it to send data at the same time or try to receive data while the Wi-Fi is transmitting, because you're going to get overwhelmed with the Wi-Fi signal. It just has a smart coexistence, which is quite nice. So it's well suited for using with their chips. You will need a pretty beefy chip. So in this case, the NR53, which I think is a Cortex M33, if I recall correctly, and it has, probably a mega flash and like a quarter meg of RAM. You do have the entire Wi-Fi driver running on the NRF53, including the SSL stack. So, it's non-trivial. You will need to have a good amount of memory to buffer your packets, send data back and forth to the chip, which has, it has its own ARCs and TX buffers, but like you're still going to have to do quite a bit of work. So you can't run this on a low grade microcontroller. You'll need something, probably a Cortex M0 at the least, to connect through their networking stack. They do have code available through the SDK, which of course is really good. There's Zephyr, so that's a RTOS. It's very popular. I do recommend it. I'll show later that there's an example that somebody got the Zephyr version working, and they have a step-by-step instruction on how to do it. There's also OSAL, that's like a operating system something layer, interfacing layer. So in theory, you could port this to other platforms if you wish. But again, a lot of people so far have been using they've basically been using Zephyr within the NRF SDK. So it's interesting about this is because you're like, okay, like there's a separate chip, and like, what's the deal? Why didn't they just make like a chip with one of their ARM Cortex cores inside? But it reminded me a lot of the NRF 8001. So the NRF 8001 is, for those who remember, was Nordic's like first Bluetooth chip. Again, like 8 Bluetooth 1 first. And this was an SPI. You can see the SPI pins at the bottom to BLE converter chip. And this was like actually kind of like the first chip that allowed you to do something like this. Previous Nordic had been doing like the NRF 24 series, which is about 2.4 gigahertz. And then they were like, we're so good at 2.4 gigahertz, so let's go and do Bluetooth LE. And so they did Bluetooth LE, and we, there's books I think that are even published about using this module. One of the nice things about it, it was simple enough that you could connect it up to something like an Arduino. We have a bunch of projects. This is like an ancient project where you wire this up to an Arduino. I think it was Arduino Nano or Pro Micro. I don't remember exactly what that board is. Some NeoPixels, and you can control it through our app.
Pro Micro, because I think that's the one that we helped. We were credited on helping design it.
Yeah, the Arduino Micro.
Yeah.
Right. Sorry. It's been a
It was
hot minute.
It's been a lifetime.
It's been a long time. And it's funny. It's like you can have 20 characters because I think that's the limit of the packet size that you could send through the NRF 8000. I mean, we could have had multiple packets, but it was, that was the limitation. It's a very early implementation of Bluetooth Low Energy. But this, this was how you basically use Nordic stuff to connect to BLE. And then they very quickly updated it and created the NRF 51, which was a Cortex M0 with like, I think 16K of RAM. Very minimal, but just enough RAM that you could run their Bluetooth stack, the soft device. On this Cortex M0, you could program it. It was like standalone. There was code that you could run that used the built-in Bluetooth interface. And then, after the NR51, they improved it with the NR52, which is a Cortex. I think that was when they went to the M3 or M4, Cortex 52 840, which is an M4, and now the 53. So it seems like their natural progression is to start with the SPI separate interface, and then they build up. And then I have, I don't work for Nordic. I can't speak to them, but it seems reasonable to me that they're going to update their design for the NRF 7002 and eventually make a version that has an ARM Cortex inside, which would be really cool because Nordic is really, really good at low power, well documented, stable API chipsets, peripherals. Like their stuff is very high quality, very low power, and they have very good support for their API layers. They have like lots of very smart engineers that work for them. And so, even though you can get cheaper Bluetooth chips than Nordic, you can't get better ones, right? So, I think it is interesting that they're, when their approach to getting into the Wi-Fi space is to go with something like that has dual bands and has like this really cool interface, and it's a very fully featured advanced chip, and then they'll probably start integrating it afterwards. There's also a development kit. So this features on the right, you can see there's the NRF 7000, and then above that, I think is the NRF 53. And then there's the native USB above it. And then to the left, there's kind of the Arduino mega-ish pinout zone. All the pins are brought out on the NRF 53. Because remember that the 7002 is just acting as a peripheral. You can connect like shields and stuff to it. And there's a Sager J-Link interface for debugging. So this is kind of their dev kits. They're fairly inexpensive. Then you can see there's two antennas. There's a 2.4 gigahertz and a 5 gigahertz, as well as RF test points. Yeah, here you go. There's Sager debugger, debug ports, built-in current measurement, capability, 5340 SoC, antennas, and so you can also test the coexistence stuff with that. I also, just kind of peeked around. This chip is quite new. Like really, I think they just put them in stock. I did see Fanstel is going to be releasing modules. So this could be kind of nice because you just pop it on, connect it to SPI, and like this is ready to go. So you can have gigahertz band. And I do think that you can use the NR52, 53, or 91, but it'll probably get ported to other chips as well. So your IMX series, maybe your RP2040. Could all take advantage of this. And DigiKey carries the Fanstel module. So when they exist, I'm sure DigiKey is going to stock them. There's also a couple blog posts that I checked out. Weren't too bad. There's the, step-by-step instructions on how to implement MQTT with the NRF 7002 on that DK. They also have a nifty provisioner app. So because they're kind of expecting you to run this on their cellular or Bluetooth um, capable chipsets as like the host controller, you can then use their provisioner, and like they have like quick code that you just kind of link in, and now you can put in the Wi-Fi credentials for like a device for a product via the BLE, and it kind of all happens all magically. So you don't have to write that part of your code, but you're taking advantage of like, instead of doing the access point thing, which you can do, but I find very annoying, you can use Bluetooth instead. And then finally, I did see also Goliath, which is a Friends the Fruit, and they have a IoT service. They did a really nice step-by-step tutorial on using Zephyr with the NRF 7002, connecting to their API, and then doing remote procedure calls back and forth to your main board. So then it didn't look too bad. It was like, oh, you just have to clone Zephyr and then you run it. It's very advanced. It's a very powerful programming system and debug framework.
Available on DigiKey.
Yes. And
So
they're in stock, although it didn't load, look like. But there were 5,000 in stock earlier. You should press refresh later. But there were 5,000 in stock, a couple bucks a piece. And the eval boards are not in stock yet, but they will be soon.
all right, and they have a short video. We're gonna play that, and then we're gonna jump right into Top Secret, which we have a bunch of stuff, and then get to your questions.
Hi, let me introduce you to Nordic's first Wi-Fi solutions. The NF 7002 dual-band Wi-Fi 6 companion IC and the NF 7002 development kit. Finally available for anyone to start developing. The NF 7002 is Nordic's first Wi-Fi product. It is a Wi-Fi 6 companion IC, adding Wi-Fi connectivity to a host processor. As with all of our products, our focus for the NF 7002 was on what we do best: low power wireless. It takes advantage of the new low power features introduced in Wi-Fi 6. Target wake time allows the client device using the NF 7002 to negotiate a wake-up schedule with the access point it is connected to. This gives you excellent control over the responsiveness and power consumption of your Wi-Fi devices. Orthogonal frequency division multiple access, or OFDMA, divides up the channel bandwidth to allow multiple devices access simultaneously. A Wi-Fi channel can be divided into several subcarriers. This is super useful for dense deployments with many devices that don't need to send too much data, like sensor arrays. Not all current Wi-Fi networks out there are Wi-Fi 6 capable. That's why we've made the NF 7002 backwards compatible with older standards. This enables you to build a device that can be implemented into most existing networks. For similar reasons, we also made the NF 7002 dual band capable, supporting 2.4 and 5 GHz. This gives the advantage of higher 5 GHz speeds and a less congested band, or use the 2.4 GHz for better range. In summary, this enables you to build versatile products that integrate into most
on NPR.
Okay, we're gonna go right into Top Secret. So we're gonna play some of the videos that we've been doing late at night, and these are all stuff that's coming out. Some of it is like real time, and then we're gonna go into 3 new board designs that you just sent over. These are hot off the press. So here we go.
Hey, lady, what is this?
This is an IntelliKeys USB. This is an accessibility board. And what we're going to try to do is get it working with our USB host feather with the RP2040, where it's a very low cost feather that has USB host built in. And what's something that's really interesting, but we'll do a couple of videos, but it uses these custom overlays. So this is a touchpad, and then you have different overlays that have different capabilities, and it knows which overlay you just inserted. So you see these like little black marks here, like on the other side. It has, this one has like 3 marks. Inside here are some photocells that can detect which overlay got inserted. So like when this gets put in, like so, it goes beep. Hold on, if it goes beep. And then if you see on my notepad as I type,
Wow, this works.
yeah, except I can't type very well. But those are custom overlay makers that you can do. So this is kind of neat. It's like a very useful accessibility tool. Thanks to AT Makers who made a driver and also let us know how cool it would be if this was able to work on a device that's just pre-assembled, ready to go, plug and play. Because the internal chip in here, you might be wondering why can't you just use it now? You can on Windows 10, but it has a special chip inside. It's like the Cypress Easy USB family that downloads firmware when it connects over USB, which means that basically, since this isn't made anymore, it's really hard to get this working with modern operating systems like Windows 10 or Mac. It's not going to work with devices like iOS or Android or Chrome that don't have the special firmware downloader. So this is going to be like a little HID remapper type thing where it's going to detect that an IntelliKeys is plugged into here, download the firmware in, and then turn it into a normal keyboard. So this will just look like a regular keyboard with all of the overlay stuff working. So hopefully coming soon to the blog.
All right, Lady, what's this?
We are testing out some new feathers here. This is our RP2040 Bones board, RP2040 basic with USB-C, buttons, 8 megabytes of flash. And in the space left over, we've got an RFM69 module. This could also be a LoRaWAN module, a LoRa module that can run LoRaWAN stack on the RP2040, but this is just a plain RFM69. We've got a spot for a wire antenna, a UFL antenna connector, so it's good for connecting larger antennas, a STEMMA QT, and I've got another one over here, and if you back up a little bit, you'll see when I press the button on one, it appears on the other one. So hold on, I'll fold this over. And then I press the button on here, it sends the message over. So they're communicating with each other, and I also get the signal strength, which is a good way for me to test that my antennas are working. So all are good. Next up, I'm going to try LoRa.
All right, Lady Ada, what is this?
This is a new feather. This is the RP2040 e-ink feather. So we took our Bones file, which is an RP2040 with 8 megabytes of flash and a STEMMA QT, and in a little space over to the right, instead of a radio module or DVI connector, we've got the circuitry for e-ink display. So e-ink displays kind of all use the same 24-pin connector, which means that this can drive displays from like 1-inch diagonal to 7.5-inch diagonal, because again they all use the same pinout. Nice beefy power supply here and all the circuitry you need. And then it's connected to the 8 extra GPIO pins that are not brought out on the feather. So you get the SPI, you get the chip select, reset, all that good stuff, and a power pin for the NeoPixel so it can be used in low power mode. So I think it'll be good for standalone e-ink projects coming soon to the Adafruit shop.
Hey, Lady Ada, what is this?
This is a prototype of our RP2040 USB host feather. And now you're probably saying, hey, the RP2040 only has one USB port. Well, not if you bit-bang USB host with PIOs. And we've got that added to teeny USB. And over here, this inductor is part of a 5-volt boost converter, which means you'll be able to run off a battery as well, which could be kind of neat. You got STEMMA QT, 8 megabytes of flash, all the buttons and crystals, and yeah, you got a port there. And then what we're running is the HID device report, which is an example in USB. So when I plug in this SNES like joystick thingy, you'll see over there the report, and you can even see as I press the buttons, different bits go on and off. So this is receiving HID keyboard or mouse data just fine, ready for some future projects soon in the Adafruit shop. How cool is that?
All right, Lady Ada, what is this?
I'm testing out a new Feather Bones board I made that is specifically designed for e-ink displays. So it's got RP2040, battery backup, buttons, and STEMMA QT, and the little area here is the e-ink driver circuitry, and I'm testing it out with 2 displays. One is your everyday 2.13-inch tricolor display, and it's working nicely there. And then this one is a cool 5.65-inch 7-color ASEP display. So these displays have 7 different colors: red, yellow, white, green, black, violet, something else that I'm orange. And And so we have some art from Bruce that has some cool Adafruit characters. This one just takes a really long time to update. But, as normal e-ink goes, once it's been updated, you can remove the power and it stays on. So it's kind of neat, like so.
All right, Lady, what is this?
This is Canception. We've got this new board we're going to put in the store. This is a CAN bus transceiver. It uses the TJ 1051, which is a nice high-speed CAN transceiver from NXP, and you got like an on-off switch for the termination, and here it is. So you could use this with a board that has native CAN, like this ESP32S2, and then to test it, I want to have like another CAN device that it talks to. So I've got a Feather M4 CAN here, and every time the LED blinks, it's sending a message over the CAN bus lines, and then I press this down, and it says, okay, I've received the message on the secondary. It's connecting to the native CAN on here. It says I've received the message from the Feather M4, and I'm even powering it from the same board. So it makes for a very quick test for this transceiver. Very nice. In the shop very soon.
All right, Lady, what is this?
This is a new product we're about to put in the shop. It's our CAN bus feather wing that features the MCP 2515, which is an SPI CAN controller, and then there's a CAN transceiver on here as well. You're supposed to use this with any of our feathers, even ones that don't have native CAN controllers in them, to connect to and send receive data on a CAN bus. Some devices like this Metro ESP32S2 have native CAN, and so we're actually kind of doing a thing where it tests itself by having the native CAN talk to one of our CAN-PAL transceivers, which then connects to the pads over here on the CAN feather wing. And so one CAN bus goes through SPI, one goes through native, and they send messages back and forth. And when they beep, you know that data was sent successfully back and forth. So this board is fully tested and ready to go in the shop to add to your next feather project.
All right, Lady, what is this?
One of the things I've been showing off lately is how we're using this RP2040 to program ESP32 modules and chips very quickly. So this is our Wi-Fi airlift that uses an ESP32. And I used to use a Raspberry Pi computer to program the ESP32 using ESP tool. But thanks to the really good code from TAC that pre-compresses with gzip the file, it's actually quite fast to burn the Nina firmware over UART this time, 2 megabits per second. It does MD5 check, and then the last verification is to make sure that this ESP board is working well. We, over SPI, ask it to scan the Wi-Fi and verify that it sees the Adafruit access point, and if it does a little rainbow dance over here so that we know that it's passed test. So this new version of the Airlift Featherwing with Stomach UT is coming to the shop soon.
Data, what is this?
This is a tester for the upcoming product number 5710, which is the DVI Feather, to just update this board, which came without a silkscreen. But new PCBs will come in, and here's the board under test. And what's neat is we're using our own 5-inch HDMI display as the DVI output test. So this Pico loads over USB the UF2 to do the test, does a GPIO test, and then, hey, check that out. The test OK symbols signal appears on the DVI display, so that's how we know that the HDMI is working. So this tester is pretty fast, 8 seconds to load all the firmware and do the DVI output test and all the GPIO. So pretty happy with this. It'll be in the store soon.
All right, and then you've got some boards.
Yeah, I decided I'm kind of getting back to some designs from a couple of years ago. So this is a DWM. This is a ultra wideband chipset module. They're not cheap, but like they kind of do one thing that no other modules do, which is indoor positioning, which is really hard to do. So this that's the module kind of above your head. And yeah, this design was from 2020 or 2021, and then yeah, we couldn't fabricate it because we couldn't get modules. But the modules are available again. So this is the Featherwing version, and the next thing is this is the Feather RP2040 version. So there's like a little bit of space over there where, you know, we'd have the DVI port or e-ink connector or whatever. So I just stuck that module instead, and the antenna hangs over, but that's okay because you actually want to have the antenna unimpeded. It's not unusual to see them hang off of boards because they give the better you want like a lot of empty space around it so you can get clear signal from the other nodes to do that pinpoint locations. This is the 16-bit I2C DAC chip. So we have like a couple 12-bit DACs in the shop. But let's say you want more bits because you're like, I want really precision analog output. This is a nice analog devices chip that does a 16-bit output. It has a built-in temperature compensated 2.5 volt reference as well.
And that is the gigantic amount of top secret we did this week. Whew, got
So much.
Okay, we lined up some questions. We're going to do those, and then we're going to bounce. Like I said, this week was all about retro and top secret because we want to get to all those. So next week will be double plus new products.
Yes.
Okay, they're lined up here, Lady Ada. I'll answer some of
Okay.
these. You can do these. First one, does anyone make breadboards with more columns?
No, they don't. There's a standard breadboard style. What you can do though is they snap together, so you can take two half-sized ones and you snap them together sideways, and then like it's kind of like you have more space.
I'll answer this one.
Double wide.
Oh, anyone can ask about AdaBox status in the chat. It's always okay. The times that it's frustrating is when, we'll let someone know, hey, like, here's the status. And they're like, no, I demand it to be sooner. It's like, we've been in a chip shortage. But the latest is we have our prototypes, we have the redesign, and we just need time. So we have
Just to get.
yeah, we just have like 5,000 or so that we have to prepare and get out. So we're still hoping that it's in spring. It's spring now. New York is starting to get
Yeah,
warmer.
I work on it a little
Yeah,
bit.
we have the prep for the boxes that they all go in.
That's all done.
That's all done, and there's no reason it won't go out. I guess that's good
No,
news.
it's gonna happen.
Yeah. Over the last year or so, there was lots of reasons it just couldn't go out. There wasn't parts. So, anyways, it's a good one, and it's still shipping. As soon as we know, like, hey, it's 4 or 5 or 6 weeks out, we're gonna let everyone know because we have a lot of work to do. There's credit cards that expired because it's an authorization. People have moved addresses, so we're gonna spend a lot of time making sure if you're a subscriber that it's getting to you. Next up. I usually see PCB designs as 2 or 4 layer. I know there are boards with more layers, but curious if there's any limitations on the maximum number of layers a PCB can have beyond manufacturing cost and complexity.
I've seen 16 layer. I think they can go up to 20 layer. I mean,
What would that be for?
Motherboards, where you want to have like a 32-bit bus and it has to be like all, you don't want to have anything in the way and you want to
So
get
that's
from
what you
one
would have
A to B.
multiple layers.
Multiple layers, lots of ground planes. RF boards will have a lot of layers. Anything tightly packed, cell phones obviously are going to have easily 8 to 20 layers,
Okay.
Without question. But it's the cost goes up quite a bit, and the yield goes down. It's harder to make sure that the job, it's hard to know what's going on each layer. Make sure that they're all aligned. So I stick to 2 layers, sometimes 4 layer. For the cutie pies, I'll do 4 layer because they won't fit. It's a double-sided design, and the parts.
Here's a question that someone could try to. You could use like a web search engine or a chat GPT, a chat PCB. Maybe some
use your 20th anniversary math.
Yeah, no, someone could maybe look up if there's any place where someone has said, "Oh, this had the most layers of a PCB, like most layers." Like
it's a military application probably too.
You'll never the stealth bomber probably has multiple layers.
Well, I don't know. Sometimes you'd be surprised. Sometimes they have requirements like it has to be inspectable, right? And you can't really inspect it easily.
If it has too many layers, there has to be something like that. Someone knows somewhere. Okay, what happens to your prototype boards once they've been turned into a physical product? The green ones, where do they go? Do they give a special bin?
Well, sometimes they work, and if they work, and they're like the final version, they get used as the tester, to test the tester. So we call them golds. And what's nice is they're greens; they don't get mixed with the regular stock, and so we use them to verify that the tester still functions before we do a PCB run. And then sometimes I just keep them in my bins, and sometimes I use them for something.
During COVID, when there was, well, it's still COVID, but during the different forms of COVID with shutdowns and stuff, we had to use green PCBs.
Yeah, I couldn't get other colors.
Okay, last question of the night. Typical boards have a cuttable trace if you want to do something like disable LED on the board. Do you see ultra mini switches becoming small and cheap enough to allow for faster change or to avoid resoldering? That's an interesting idea.
I've seen them, and like I'm a little mixed because they can be damaged. They're susceptible to water or moisture, and they'll oxidize. So I'm not a huge fan of switches, especially for something where not if I don't feel like in the normal use of it, you're going to go back and forth.
Okay, I'll answer this one from the other chat because we've said probably before. Circuit Playground Express RP2040, yeah, probably.
Yeah,
Probably. And I think
okay,
that is it.
Thanks, everybody.
Show for tonight. Thank you so much, everybody. This has been an Adafruit production. We appreciate all of your help and support and all the things. Don't forget the code is Redbook.
Yes.
For this Redbook. We'll see everybody next week. Special thanks to Jesse May behind the scenes. Special thanks to our team.
Thank you to the Redbook.
Our customers, our community, everyone for helping this thing go. And congrats to all of us working on this CircuitPython thing. 100 libraries.
Libraries.
Yeah, community bundle. Here is your moment of Zener.
Good night, everybody.